Hello everyone, welcome you all. This is Ankish, and today we are going to solve a question lucky numbers in a matrix. Okay, so let me start with the question description. So, in this question, it is saying like you have M cross N matrix. Okay, so the question is saying you will have M cross N size of matrix which all have distinct number. Okay, so each element will be unique in this matrix for sure. Okay, return all lucky numbers in a matrix in any order. Okay, तो अपन को सारे लकी नंबर रिटर्न करने हैं, ठीक है. अब लकी नंबर क्या है? अ लकी नंबर इज एन element of the matrix such that it is minimum element in its row and maximum in its column. Okay, so the question is saying you will given a matrix of size m cross n, and you will have to return all the lucky numbers. Okay, makes sense, makes sense, makes sense. Okay, so in this matrix, a lucky number is a type of number which is minimum in row. Like इन चारों में से मिनिमम होगा, which is minimum in row, but it will be maximum in column. Okay, so this number will be my lucky number. Okay, so after doing this, my basic approach comes to my mind. Okay, so I will try to iterate all the matrix. Okay, let me just copy that matrix for you and just move ahead. Okay. So basic approach comes to my mind. Like you have given this matrix, you have to return all the lucky numbers. What I can do is like I will iterate on each element of the array, 2D array. Okay, let's say first I will be here, then I will be here. Okay, when I am iterating through every element of array, okay, eh, here I will check whether it is minimum in row or maximum in column. Does it make sense? Here I can check whether a current number is minimum in row or maximum in column. If this current number satisfy that case, I will add in my answer. Okay, makes sense. So according to me, the time complexity will be that for 0 to n or 0 to n. This is for traversing all the elements in array. While traversing in between them, I have to check for particular row and for particular column. It will be, so the time complexity here will be approx, you can say like time complexity will be m cross n, and for a particular element I have this this cross. For a particular element I will have to check for their row and for their column, and the space complexity will be this. Space complexity will be often since we are not using any extra space. Okay, so now my question is, can we improve, or can we go to better approach? Okay, let's see. Okay, so we have given this matrix. Okay, instead of, okay, we have given this matrix. Okay, okay, okay. Instead of calculating for every element in an array, can we just make can we just make two array? Okay, so this will store my column maximum and this will store my row minimum. Can I just say that? Okay. So in that case my column maximum will be 15. In that case my column maximum will be 18. In that case my column maximum will be 14, and in that case my column maximum will be 12. Same for here. Can I see, like, in this case my minimum is 1, here my minimum is 3, here my minimum is 12, and here my minimum is 6. Okay, okay, okay. If I can simply say, if okay, so firstly I will calculate both these. Okay, after that I can simply say I will traverse to every element in a LN. Like, firstly I will traverse to every element in an array. Like here, I will simply say whether these two is same or not. It is not, so hence this is not my lucky number. It is not even minimum. When it is minimum in my row, but it is not maximum in my column. For this element, I can simply say this is also not my lucky number, since it is not minimum in my row. For here I can simply also say that, for here I can simply also say that when you will have a column minimum, row minimum and column maximum is same as that element, I can say this is my lucky number. Does it make sense? Does it make sense? So let's see a code for this. And also for this, the time complexity will be like of m cross n. How many times I will be doing? It will be cross 2, so it is constant. So time complexity will be 3. But for this, the space complexity will be O of m plus n. This is for row maximum. This is my column row minimum. This is for column maximum. Okay, let's see the code for this question, for this approach. Okay, so this is the code. Let's see. So here what I am doing, I am I'm making array of size n, and here I am making array of size m, because the m and n can be vary. So first of all, let's say I have an array element like this. So the column there will be of size for column maximum, which is also here, which is maxi, and here the mini is my row minimum, or either my column maximum. Okay, doesn't make sense. Can I just say it to negative infinite? Or here, since I want to find the minimum, I can just say it's to some greater value infinite. Okay. Or while traversing, for every element, I am looking for the column maximum and row minimum. Here, for every element, here while traversing, I am looking for uh, column uh, column maximum, which is this column maximum. For every element, I am looking for column maximum and row minimum. Okay, after calculating all the rows and columns, I can simply say if the mini of I means let's say I have two, I have like a column maximum, which is also equal to maxi here all okay, and I have row minimum which is also equal to mini. I can simply say when these whenever the two element matches in them, let's say these two matches, this will be my luck this will be my lucky number. Can I say that? Yes, I can. Yes, I can, because here it what it because here this is what I'm doing. I'm going to every element of array. I'm trying to matching with same. Here it is called matrix of ij. I'm trying to matching it with this as well as I'm trying to matching it with this. Okay, if it match, so I can simply say since all the values in the array is unique, then if there is common element between row minimum and column maximum, this so that element will be my lucky number. Oh, it does make sense. Okay. Okay. For that, the time complexity is m cross n, but the space complexity is this. Now, my question is, can we improve this? Okay. Okay. Let's think. Firstly. So what here I'm doing? Firstly, I'm calculating like row minimum and column maximum. Okay. Let's say here I have a matrix like that. Okay. Okay. I can simply say in this matrix, in this row, this is my minimum. Okay. In this row, this is my minimum. In this row, this is my minimum. Okay. Can I just simply say? Can I just simply say, since this is my lucky number? Can I just simply say this is my lucky number? Okay. Okay. So which means the element in the column without them is less than 12. Okay. Can I say the element these element will be less than 12? These elements will be less than 12. Yes. Yes, I can see. Also. For sure, what I know, in this row, my 12 is minimum. 12 is minimum. So can I just say, in this row, every element will be greater than 12? Yes, I can simply say. Yes. Yes. So my question here is, can in this area, can there will be any lucky number? To be in this area, the lucky number should be minimum of their minimum of their row, which simply means since these two element means is less than 12. then these to be lucky number in that area, these elements should also be less than 12, or we can say should also be less than 2 or 7. Okay, okay, okay. So which simply means these elements should be less than 12, and also to this element be a lucky number, it should be maximum in column, which since this element is greater than 12, to be maximum this element should be greater than 12. Okay, so can we say this is the contradicting part, where if I want to get here the lucky number, this only where if I want to get the lucky number, this element should be greater than 12, also to be less than 12, which simply means there cannot be another lucky number. Can I say that? Yes, you can. Okay, so for sure till we know कि there will be only one lucky number. Okay, to like to explain this in more simpler form, can we say, let's say I have here two lucky number representing x and y, and there will be some element. So here we can simply say x will be less than a and y will be bigger than a. Hmm. Since as x will be less than a and y is bigger than a, we can simply say that my x, my y is bigger than x. Can I simply say that through this combination? Hmm. Let's say I have another example, like same these lucky number. I have some number here. Here I can simply say my y is bigger. My y should be less than my b, which means b should be big, and my x should be bigger than my b. Okay. In that case, I can simply say my x and y here. Like my x is bigger than my y. Can so it is not possible like that. So here the case where it is saying my y should be bigger. Here the case which is saying my x should be bigger. So this is not a possible case since it is contradicting contradicting each other. I can say, I can say there will be only one lucky number. Okay, okay. There will be only one lucky number. So my question is now, how will I find my lucky number? Hmm? Let's take the same example here. Okay, I've copy pasted already. Okay. To find the lucky number in this array, firstly I have to find the minimum in each row, minimum in each row. Let me just copy first this one so that if I need it again, I can just hmm, okay. Find the lucky number. Firstly, I have to find the minimum in each row. In that case, my 1 is minimum here, then my 3 is minimum here, then my 12 is minimum here. Okay. If I am thinking, okay, here the 1 is my minimum, and 3 is my minimum. Let's say you have same example. You have an array which consists of elements. So first minimum is here and second minimum is here. If my first minimum, which let's say this is like x1, and I will say this x2. If my x2 is greater than my x1, in that case, I can say this can't be my lucky number. Be my x1 will never be a lucky number. Why? 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 Okay. Since that was the case, okay. Here. Since one is greater than uh, three is greater than one, and it is also minimum in row. Hmm? I can simply say the remaining element will be also greater than this minimum element, this x2. If my x1 is greater than x2, I can simply say the remaining element in that row will also be greater than my x1. Does it make sense? X1 will either have, okay, so in row, x1 will either have 9, will either have 8, will either have 7, or will either have x2. So for sure, what I know, in column x1 will not be my maximum. X1 will not be my maximum. Okay, makes sense. Okay. Okay. So for sure, whenever I found my minimums, next minimum is greater than my previous minimum, I can simply say this will never be my lucky number. In that case, also I can say 12 is greater than 3, or the other element will be this. So for sure, in that column, in column of 3, it will never be my maximum. Hmm. So it will never be my answer. Then I find 12, then I find 6. So 6 is like less than 12. I can simply say this will never be my lucky number, because this will never be my lucky number because it already have like greater values in column. Okay, it does make sense, it does make sense, it does make sense. So what I am doing here is I'm finding minimum in each row. I'm finding minimum in each row, and from each minimum, like I'm finding minimum of each row, it will be 1, 3, 12, and 6. I am taking maximum, which is 12. Yes, I'm doing the same thing. So now, for sure, I don't need to store them now. I don't need to store them in my so-called row minimum array. I can simply use a row min, which will store my row minimum values. And after finding a row minimum here, it will be 1. Here it will be 3. I can store row minimum, mini, maxi will be max of this value itself and the value I'm getting. Yes, 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 yes. We can do this. In same scenario, let's say I'm trying to find the column values, column maximum. Hmm. Here it is 50. Okay, here it is 18. After that, I will do 14. Okay. 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 Can I just say, since my maximum in this row is my maximum in this row is 18. My maximum in this column will be 18, which simply means these all element these all element will be less than 18. These all element will be less than 18. Okay, then I find 14. Hmm. So can I just simply think these all element will be less than 14? These all element will be less than 14, and all these three elements will be greater than 18. Ah, to be a lucky number, it should be minimum in row. Okay. Since I have found this, I found this element is 18, this element is 14. I can simply say it. There will be a there will be smaller element present in this column, which is this. Can I simply say, this will be my, this can't be my lucky number, because to be lucky number we should have a minimum in row. Since we have find a lesser element, then this can't be my lucky number. Okay, okay. Because we already know here we have 14. All the elements will be less than 14 to be a lucky number. To be a lucky number. To be in a row, it should be minimum. For sure, what I know here, it is not minimum. It is not minimum because we have found that case. We have found that case. Key in this column there will be a lesser element than 14, and here it can't be a lucky number. So can I simply say that? Can I simply say that I will try to find the maximum, the maximum, the maximum, the maximum. Okay, okay. And from that maximum, I will try to find the minimum. Why? 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 Because if I am trying to find the minimum, then these element also will have less than will be my the max in this row. These element will be also my less than 12. These all element will be my less than 12 for sure. Since it is less than 12, I can simply say that uh, previously column maximum will never be my lucky number, because let's say here I have 14. Here I have found 12 to be a column maximum. Previously the column maximum is 14. Okay. I can simply just call maximum is 14. Okay, I found this here. So in that case the column maximum is 12. To be a lucky number, it should be minimum in row. Since I have found all those elements will be less than 12, less than 12. Uh, so since I find, so I can simply say these all elements like 2, 7 and 11 will be less than 12. And here to be a lucky number, I need to be a minimum in row. Minimum in row. It should be a like minimum in row, which is not possible, because we can simply say 14 is greater than 12, will also greater than all other elements present in that column. So I can say column element. So for sure, in a row, I will either have this 12, or I will either have this column element, which simply represent in this row. I will have minimum. I will have a smaller number than 14. है ना? I will have smaller number than 14. Okay. Okay. So can I simply say that in that case, I have to find my all minimum. Okay, so I can simply say that I have to find my all minimum, and from all minimum in row, I have to find maximum of all of that. And in my column case, I have to find my all maximum column. On from this all maximum, I found to minimum. And I simply say that if they both match, means our element satisfy both the condition to be a minimum in row and maximum in column, then it is my lucky number. Yeah, it does make sense. It does make sense. So let's see the code for this, and try to understand it properly. Okay. So here it is. Here the code for this is. So what I'm doing here, firstly I'm trying to find row minimum maximum, which is nothing but from all the rows I will first try to find my row minimum, and then from all the row minimums, let's say x1, x2, x3, x4, then I will try to find the maximum of all of them. Let's say it is x3. This is what here I am doing. For column to be a for column, like these are my four columns. It should be y1, y2, y3, and y4. I'm These are all the column maximum, and from all of this I'm trying to find minimum, which is, let's say, y2. And now I will compare if these two is equal. This Then I can simply say this will be my answer, or or there will be no answer. Okay. For this, the time complexity will be around of n cross m, and the space complexity will be reduced to of 1. Okay. So that's it for the let me just submit for you. And Thank you. Let me just submit for you. Okay. Okay, it does submit. So thank you everyone. Uh, if you like the solution, please like the video, and if you have any doubts, please let me know in the comment section. Thank you.